Hi everyone, today let's solve LeetCode 100 same tree problem on DKodeTree. It's a classic problem, it's a pretty good one for understanding the tree fundamentals. The problem gives us the roots of two binary trees, say P and Q, and asks us to determine if they are identical both in structure and node values. That means the frame of both the trees should be identical and the values at each corresponding nodes should also be equal. If we see this example, the structure of both the trees are different. This tree has a left child only and this tree has a right child only. So definitely the answer is false. And in this example, we can see that the structure of both the trees are same, but when we compare the values of these two nodes, we can see that they are different. So the answer is false. And coming back to the first example, as both the trees are same structurally as well as value wise, so the answer is true. Now let's understand how we can solve this. So whenever two roots P and Q are given, to determine that they are same, we simply need to check three things. The value of node P must be equal to the value of node Q. The left subtree of P should be identical to the left subtree of Q, and the right subtree of P should be equal to the right subtree of Q. So we will not only check a single node, we need to check the entire subtree. Now here's the cool part. Say when we are checking if two subtrees are identical or not, we can take the benefit of recursion and use the same function that we are using to check if two trees are identical or not to also check whether two subtrees are identical or not. Now whenever we use recursion, it's very important to handle the base cases. Say if both P and Q are null nodes, that means we are comparing two empty trees. As they are both empty, so we need to return true. This can also be understood as we have reached the end of both trees. Say if we take the node 3 here, both the left child and right child of 3 are null. So whenever we will be comparing this null node with any other null node, then also this case will arise. This implies that so far they have been identical, so we will return true. The next base case is if one node is null but the other isn't. Say P is null but Q is 2. That means the structure is obviously different. So we return false. Now if both the nodes exist, we compare their values. If they have different values, it's definitely a false. And if they are equal, then we will recursively check their left and right subtrees. Since we have to visit every node in the tree, so the time complexity will be O of n, where n is the number of nodes in the smaller tree. The space complexity is also O of n. This is because of the recursion stack which grows with the height of the tree. And in worst case, like in a skewed tree, the height of the tree can also go up to n. So now let's dive into the code. So first of all, we will check the base cases. If both the nodes are empty, that is if not P and not Q, then we will directly return true as empty trees are equal. Now we need to check our second case, that is if one of them is empty. If not, P and Q, and we can return false. Also note that this condition is exactly same as not P or not Q. You can use this condition as well. Now if the control has reached this point, we are very sure that this condition is false. That means at least one of them have some value. For this condition to work correctly, the order of these two conditions are very important, because if you want to check this first before checking this, then you may need to change this condition to something like P and not Q or Q and not P. Now if the control has reached this point, then we are definite that there are two nodes. So we will return our result as if P dot value and Q dot value are same and self dot is same tree, P dot left comma Q dot left and self dot is same tree, P dot right comma Q dot right. Note that if the first condition is false, then the remaining conditions will not get executed. This is called short circuiting of operations. Only when the value of node P is equal to the value of node Q, then only we will recursively apply the same function to the left subtree and the right subtree. So this is all the code that we needed. Now let's run this and check if it works. We can see that this works fine and is quite efficient. If you found this helpful, do hit that like button and subscribe to DKodeTree. Thanks for watching. See you in the next video.